In previous class, we have seen some of the concepts which are used in the descriptive statistics, which can be used to summarize the data. To know the reason why something had happened, we need some techniques. Those techniques are called diagnostic analytics techniques. These are based on inferential statistics. Let's discuss some concepts related to inferential statistics. It is based on some probability distribution. So let's discuss some concepts related to probability distributions. Random experiment. It is an experiment whose outcome cannot be predicted before conducting that experiment. Examples of random experiment are tossing a coin. Means before tossing that coin, we cannot know whether it will result in tail or head. Same thing for rolling die also. These two are the example for random experiment. Random variable is a function which maps real number for each sample point in the sample space S in a random experiment. Example, tossing 3 coins. Sample space will be this one, means 3 heads, 2 heads and 1 tail, 1 head, tail and another head. Like this you have your entire sample space. If you toss the 3 coins, a random variable to count the number of tails in the experiment. So this X is called the random variable. It will map this sample space to some real numbers. Here we need to count the number of tails. How many tails are there here? 0 tails. So it will be represented with 0. This point will be represented with 1 because 1 tail is there, and you can continue like that. 0, 1, 1, 1, 3 2s and 1 3. Random variable can be divided into 2 types. One is discrete random variable and continuous random variable. Discrete random variable take only finite set of values in finite observation intervals. If you roll the die some n number of times, you will get only possible outcomes 0, 1, 2, 3, 4, 5 and 6. Means it will take finite set of values. Continuous random variable, it takes infinite number of values in finite observation interval. Suppose if you measure the time taken to fill a water tank, if it is 12 minutes, if you do the same experiment next time, it might be 12.5 minutes. If you conduct one more time, it will give some other result. Means this random variable can accept infinite number of values. Probability distributions. It is a mathematical function that gives the probabilities of each possible value that a random variable can take. For example, if random variable x is used to denote the outcome of a coin tossing, then the probability distribution of x would be 0.5 for heads and 0.5 for tails also. That coin is fair. Probability mass function. It is the probability distribution of a discrete random variable, and it provides the possible values and their associated probabilities, such that the probabilities associated with each possible value must be positive and summation of all those values should be equal to 1. For example, if you flip the coin 2 times, our random variable is to count the number of heads. The sample space is TT, HT, TH and HH. Our random variable map the sample space into some real numbers. Here number of heads will be 0 for this TT, so 0. Here 1 head is there and here 1 head is there. Here 2 heads are there. So this random variable map the sample space into some real numbers. Let's see the probability mass function definition. It is the probability distribution of a discrete random variable, provides the possible value and their associated probability. What are the possible values for discrete random variable? Either 0 heads, 1 head or 2 heads. These are the possible values for the discrete random variable and their associated probabilities. For getting 0 heads, there is only one chance, t comma t. Out of 4 possible values, it is the only one possibility getting 0 head. So 1 by 4 it is 0.25, and for getting 1 head there are 2 chances, 1 by 4 plus 1 by 4 it is 0.5. For getting 2 heads it is 0.25. We can represent this probability mass function table like this, and it has to satisfy these 2 conditions also. Each individual probability is 1 by 4, 2 by 4 and 1 by 4. All those are greater than 0, and summation of all these probabilities should be equal to 1. Probability density function. Probability density function is the probability distribution of a continuous random variable. Let's see the definition. If x is a continuous random variable, the function f of x is called the probability density function. It defined as the probability that x lies between points A and B. Means it is the area under the curve between 2 points A and B. Here A less than or equal to B. This is A, this is B. If this is the random variable, this is f of x. This f of x can be mathematically represented like this. F of x equal to probability between these 2 points A and B, or this colored region. This can be obtained by integrating definite integral from A to B of this function, and it has to satisfy these two properties. For any x value which is between A and B should be positive, and the total area under that curve is equal to 1. Cumulative distribution function. Probability mass function cannot be defined for continuous random variables. Means it can be used only for discrete random variable. Same as that, probability density function cannot be defined for discrete random variable. Cumulative distribution function of a random variable. Another method to describe distribution of a random variable can be defined for discrete random variable, continuous random variable, and for the mixed types also. Cumulative distribution function can be defined as the probability that the random variable x takes a value less than or equal to value x. It is the probability of x less than or equal to some value small x. This x can be represented any point in this random variable. Here suppose if it is 1, p of 1 will be probability of x less than or equal to 1. This is summation from 0 to less than or equal to 1. This is example for calculating CDF for discrete random variable. Here our experiment is flipping coin. A number of tails will be the discrete random variable. Let's see the cumulative distribution function for continuous random variable. If some random variable which is following this distribution, then if you want to calculate the CDF, then you have to integrate that curve from minus infinity to, suppose if we want to calculate less than or equal to 3, then you have to integrate that from minus infinity to this 3. If values are not there for minus, then if it starts from 0, you have to integrate that from 0 to 3. This curve equation is this one. You have to integrate this curve and you will get this area. Means this cumulative distribution function can be applied for continuous random variables as well as for discrete random variables.